All right, let's look at DSMA 14. So we're going to look a little bit at what we call slope-intercept form. We were in DSMA 13, we were substituting a little bit into this, but what happens is if a line is in this format, y equals mx plus b, the m is going to be the slope. So you know how lines are sometimes very steep and headed up, sometimes flat but still headed up, sometimes headed downward. That's what the slope tells me. And we're going to look at some more in just a minute. And then the y-intercept, the b, is where it crosses the y-axis. So if I have an x and y coordinate system, the b is going to tell me where that line crosses the y-axis. So this would be b. This is really helpful when we are drawing lines. It's much quicker than having to plot points. All right, so this is just showing the same thing. Y equals mx plus b. The b is just showing you where this would cross the y-axis. Could be above the x-axis or below the x-axis, depends if it's positive or negative. And then the m in front of the x is the slope. And so what happens with this y equals 2x plus 3, the y-intercept, or where I cross the y-axis, is at 0, 3, and my slope ends up being 2. We're not going to do a lot of graphing of this, but let me show you real quick what happens. Our b would be at positive 3. I need a couple more here. And then we would actually go up 2 and over 1 to take care of the slope. I can't make this point. And then we would draw a line right there. So for m, we have what we call rise over 1, which is 2 over 1. You always have to have a fraction. But I'll show you more of that in a minute. Okay, so with this one, we have y equals 3x minus 3. So my slope is 3. That's the number sitting in front of x. And therefore, my rise over my run would be 3 over 1. Like I said, you have to have a number on the bottom. You have to have a fraction for slope. Now, my y-intercept is negative 3 because that is the number. Let me change color. That's the number at the end, the constant at the end. So we're going to start down there. We're going to start here at 0, negative 3. And because the rise over the run is 3 over 1, I'm going to go up 3 tick marks and over 1, plot that point. Then I'm going to do it again. Go up 3 over 1 and plot another point, and then I can draw a line. The slope stays the same on a line no matter where you start. So whatever point you start on, you can do up 3 and over 1, and you would get a point on the line. All right, let's look at another one. So this is again showing you a positive slope. They've all been positive so far. The slope is 2 over 3, 2/3. And so this time we're going to rise 2, but we're going to run 3 because there's a 3 on the bottom, not a 1. And so if we started here at negative 4, we would rise 2 tick marks and run 3 tick marks to get to the next point. And then we would do it again, rise 2 tick marks, run 3 to get to that next point. So a much easier way to draw a line. Okay, so let's go back into substituting again. So they gave me the equation y equals 3.36x minus 2.08, and they want to know what y would be if x is 28. So I'm going to take that 28 and substitute it in for x, right? And then just pop it in your calculator. So take 3.36 times 28 minus 2.08, and I get 92. And so as a function, your x is the input, your y is the output. Okay, so in the homework, they want you to take some of these equations, substitute in for x, get y, and then plot the 2 points. So they gave me this equation, y equals 0.275x plus 8.5. I'm going to substitute in x equals 20 for the first one. When I do that and put it in my calculator, I get 14 back out. So that's my ordered pair. I put x in, I put the x of 20 in, I got 14 back out. So that's one of my ordered pairs. Then I'm going to use the equation again, but this time they want me to put 60 in. So I'm going to put 60 in for x, put it in my calculator, I get 25 back out. So now my ordered pair is 60, 25. So now I'll just plot these two on there like we practiced in Dsma 13 and draw my line, and I am good to go. Okay, so this is the first one with negative slope. If there is a negative sitting in front of the x, then the slope is going to head downward from left to right. And therefore, instead of rising, we're going to fall. We're still going to run to the right, but we're going to fall instead of rise. So this problem's the same way. You're going to substitute 5 in for x, get 6.8 back out. So that's one ordered pair. Then you're going to put 30 in for x, put it in your calculator, and get 5.8 back. That's your next ordered pair. You're going to plot those two and draw your line. All right, so this is looking backwards. We have the line and they want to know the slope. So remember, the slope is going to be the rise over the run. Well, this one is falling. So we know our slope is going to be negative because the line is headed downward from left to right. So what we need to do is see how many tick marks they fell and how many they ran. So it looks like they fell 2 tick marks, right? So that would be the -2, and then they ran 3 tick marks, right? So they fell 2 tick marks, and then they ran 3 tick marks. And so my slope would be -2/3. Now remember, with fractions, you can either put the negative out front or you can put the negative up in the numerator with the 2, but don't ever put it in the denominator. All right, so let's talk a little bit about lines. Lines can have positive slope. That means that it's headed upward from left to right. Lines can have negative slope. That means they're headed downward from left to right. If we have a horizontal line, so that's a flat line like a horizontal road, that has a slope of 0 because you're not headed up, you're not headed down, you're just headed straight across. And then we have our vertical lines. Our vertical lines break every rule in algebra. And so the slope is actually undefined for vertical lines. So with this graph that they're showing me, it looks like the slope is negative, right? Because it's headed down from left to right. Okay, now with lines, the faster the line is growing, so in other words, the steeper the line, the greater the slope. All right, so a slope of 2 might look like this, but a slope of 5 would look like this. So the steeper the line, the greater the slope. And so in this case, because the purple line, line 2, is steeper, it has a greater slope than the other line. In other words, it's growing much faster. Okay, another one where they give you the line and they want to know the slope. Now we know it's positive because it's headed upwards, right? So let's see. If we go from this point at the origin, we would head 5 tick marks up, right? So we would rise 5 and then we would slide over. So you always start at the one point to get to the other point. So we would go up 5 and over 2. So we would rise 5 and run 2. Therefore, our slope is 5 over 2. Now, the reason it's nice to have in this form is if you have the y equal to all by itself, the slope is sitting right in front of x. It's the numerical coefficient right in front of x. And so if they're asking you the slope is just the negative 0.7, negative 0.7 is my slope because it's the numerical coefficient right in front of x. If they had asked for the y-intercept is 0, 5.8, and that is where this line crosses the y-axis. Okay, so you have to be careful with my stat lab and drawing these lines. But what's going to happen is you always want to start with the y-intercept. So here we have our equation. We know that the negative 4 on the end is our y-intercept. That's where we're going to start. We know that our slope is 9 over 4, so that's going to be our rise over run. So in my stat lab, you're going to have this little icon that looks like a line with a box around it. So you're going to click on that. You're going to come over here and click on 0, negative 4, because that's where I'm going to start. I'm going to start at the y-intercept. And then what you're going to do is you're going to head up 9. So you're going to rise 9 tick marks and run 4 tick marks. And that's going to give you your next point. And when you click on that point, the computer's going to draw the line for you. So you click on the y-intercept down here at negative 4, you go up 9 tick marks over 4, click again, and then that's going to draw the line for you. So this one's going backwards, but we know how to do this. We have y equals mx plus b. Well, they told me that the m is equal to 7, so that's going to become the numerical coefficient for x. They told me that b, the y-intercept, is 9, and so I'm going to put 9 here. And that's all they want. They just want y equals 7x plus 9. All right, this one's the same idea. However, they're then going to make us graph it. So we've got y equals mx plus b. Remember, that's my basic formula. So my slope of negative 2/5 is going to become the numerical coefficient for x, the number in front of x. The b, the y-intercept, is going to come over here. So for me, I'm going to start with the y-intercept of 0, 1/2. That's starting right here in the graph. And then I have a slope of negative 2 over 5. So I'm going to come down 2 tick marks and over 5 tick marks. That's going to give me that next point. And then the computer's going to draw that for me.